So in this video we are going to be looking at simplifying fractions which have surds in the denominator. So for example 2 divided by root 5, or on a second example 5 divided by 2 plus root 3. Now in your exams this will be called rationalising the denominator. And if you think about it, it kind of makes sense. A surd is an example of an irrational number. So by rationalising the denominator, what that means is removing the surd from the bottom. So we need to get rid of the divide by root 5 here. To do that, simply multiply the fraction by the surd. Do it to the top and the bottom. You do it to both, you're not actually doing anything, because remember, anything divided by itself is just 1. Now, the square root of anything, the square of anything times the square root of anything is just the number itself. So root 8 times root 8 is 8, root 5 times root 5 is 5, and the top becomes 2 root 5. Now, in our second one, we're going to make use of the difference of two squares. Now, if you think about it, we have A and B. If you square A, you get 4. If you square root 3, you'll get 9. I've got 2 plus root 3, so that would be this one. So what I need to do is multiply by 2 minus root 3. Do that to the top and the bottom. Obviously, you need to keep the fraction the same, so multiplying by top and bottom by the same thing doesn't do anything. If this was a minus, this would become a plus. So that gives me 5 times 2 is 10. 5 times root 3 is minus 5 root 3. You can treat that like brackets. 5 brackets 2 minus root 3. And then on the bottom, a squared is 4, minus b squared is 3. You could, if you wanted to, do 2 times root 3 and then 2 times minus root 3, but they'll cancel out. 2 root 3 and minus 2 root 3 cancel. These are effectively double brackets, so you could expand them like normal if you wanted to. So, my final answer is 10 minus 5 root 3, because 4 minus 3 is 1. So once again, we've removed the surd from the bottom. Now, in my final example, a little bit more complicated, but exactly the same principles. Root 7 minus 2 root 3, all divided by root 7 minus root 3. Use completing the square again. Sorry, not completing the square, use the difference of two squares with the 7 and the 3. It's a minus here, so I'm going to change it to a plus. And I'm going to do exactly the same thing again. Let's do the denominator first because that's a little bit easier. Root 7 times root 7 is 7. Root 3 times root 3 is 3. And I have a minus in it. Again, if you wanted to, you could expand the brackets properly. And you could do root 7 times root 3 and root 7 times root 3 with a minus. But again, they'll cancel, so don't worry about it. Now the top is effectively double brackets, which we need to expand. So we just do this a little bit slower, but again, it will all work through. Root 7 times root 7 is 7. Root 7 times root 3 would be root 21. Minus 2 root 3 times by root 7 would be minus 2 root 21. And then minus 2 root 3 times root 3, let's just put that here for a second. 2 root 3 times root 3 will be 2 times 3, which would be 6. So I'm going to subtract 6 off the end. Now we can just group it together. 7 minus 6 is 1. Root 21, take away 2 root 21 is minus root 21. And 7 minus 3 is 4. And that would be how you rationalise the denominator.